certain elements combine with each other to form new compounds which have property very different from the combining elements. And in this chapter we are going to study about that. Last year also you had chemical bonding, so you have some idea why elements combine and how they combine. This year we are just going to study the same thing in a little bit more detail. What is the electronic configuration of hydrogen?
One.
Hydrogen electronic configuration is
One.
1. What about helium? What is electronic configuration of helium?
Two. Two.
2. Lithium?
Three. Two. One.
2 1.
Two.
Next, beryllium?
Two and two.
2 1 2.
Two and two.
2
Two.
and 2 and 2.
Yeah, yeah.
Okay, this is again a metal. Okay, how do we decide whether a substance is a metal or a non-metal?
By the loss or gain of electrons. And
Mostly by loss and gain. Like if substances have 1 2 or 3 element in the outermost cell, they are most likely to be a metal. Okay, 1 and 2 is confirmed. With 3 there might be few exceptions. So lithium has 1, so it's a metal. Beryllium has 2, it's a metal again. What about boron?
281.
Boron is not 281. Going too fast. Atomic number 5,
What?
Nishika. It's all
Oh,
in order. 1 2 3 4 5. We are doing the first 5 element of the periodic table.
okay, okay.
So boron electronic configuration is 2 comma 3. Okay, this has 3 in the outermost cell, but somehow this is still a metalloid. Atomic number 6, carbon. Can you help me with the electronic configuration?
2 and 4.
2 and 4. Nitrogen?
2 and 5.
Oxygen?
2, 6.
Okay, see these elements, as you see, they have 4, 5, and 6 in the outermost cell. Fluorine has 7 in the outermost cell, and neon has 8 in the outermost cell. So mostly if you have 4 or more electron in the outermost cell, they can be non-metal. Like 5 6 7 is mostly non-metal. 4 can sometimes also be metalloids. Can you tell me quickly for these next 5?
Yes, sir. So 281.
Okay,
282.
282.
283.
Mm-hmm.
284. And 285.
You can help me with any electronic configuration among these 5 if I ask you at random.
Yeah.
What is electronic configuration of aluminium?
Wait, sir. 2, 8, and 3.
Sodium.
Wait, sodium is 281.
284 is for which element?
284. Uh, Wait, 284. 284. That's 14. Is it potassium? No, wait. Magnesium. 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 Silicon.
14 is silicon. 12
Oh,
is magnesium. Can you tell me for the next 5?
yes. 286.
Sulfur is 286. Okay.
287. 288.
Hmm. Potassium?
2881.
2881. All right. And calcium?
2882.
2882. What is electronic configuration for chlorine?
Chlorine comes after sulfur. 287.
Okay. What is electronic configuration of potassium?
2881.
Okay. Potassium comes in which group of the periodic table? 2881. Potassium belongs to which group of the periodic table?
1.
Group 1. Okay. And what is the number of valence electron in calcium?
Potassium, calcium.
Hmm.
2882. So 2. 2 valence electron.
Okay. And which to which group does calcium belong to?
Group 2.
Group 2. Okay. So here in this periodic table, you see potassium and calcium are mainly metals, and argon is a noble gas. and we had few noble gases before that also. In the last 4 pages, Kushi, we discussed about few noble gases. Can you name them in the order, like starting from the first to last?
It's helium, neon,
Atomic number?
argon. Atomic number of helium.
Yeah.
It's 2.
Okay. Next one.
Neon, which is
Atomic number.
10.
Okay.
10. Argon, 18.
Okay. So we did
Fifth,
three only.
yeah.
Chemical bond. Chemical bond is a force which holds two or more atoms together in a stable molecule. This water molecule is a stable compound where oxygen and hydrogen is connected via chemical bonds. So this line you see between oxygen and hydrogen is a chemical bond. In nature, there are many such substances. Another example could be ammonia molecule, where one nitrogen is connected to three hydrogen. So here we have like three chemical bond between them. We also have bonds between sodium and chlorine, and when they combine, they form common salt. So chemical bond is nothing, but it is just a force which is holding this nitrogen and hydrogen together here, or sodium and chlorine here together, or a hydrogen and oxygen here, and there are many such examples. Chemical bonds are of three kinds. First is known as ionic bond. It is also known as electrovalent bond. Second one is covalent bond, and third type is known as coordinate bond. So chemical bonds between two elements can have three natures like ionic bond, covalent bond, and coordinate bond. I'm pretty sure that you have some idea about what is ionic bond and covalent bond from last year. Coordinate bond is something which is very new for you. Ionic or electrovalent bond. It is an electrostatic force of attraction which holds two or more than two positively charged ions together in a molecule. So in this kind of bond, you generally have a positive charge species and a negative charge species which are connected together by electrostatic force of attraction. Okay, so here we have a positive charge species and a negative charge species. All of you know positive and negative attract each other.
Yes.
Yes, sir.
So this attraction between a positive charge and a negative charge itself is called as electrostatic force. Okay, so electrostatic force is nothing but the attractive forces between positive and the negative charge. Okay, so in ionic bond, we have a positive charge species and a negative charge species, and they are connected to each other or they are attracted to each other through electrostatic force of attraction. Such bonds are mostly formed by transfer of electron. Okay, in ionic bond, we have transfer of electron. This kind of bond is mostly formed between metals and non-metals because metals are those which gives electron and non-metals are those which takes electron. So always remember in an ionic bond, it's metal. If the ionic bond is between a metal and a non-metal, metal gives electron, non-metal takes electron. And the number of electron gained or lost in this process is called as electrovalency. Let's now experience this, how this actually happens in case of certain molecules. Sodium chloride is a compound, it's a molecule which is formed by sodium and chlorine together. Okay, so in this case, one sodium and one chlorine combines to form a sodium chloride. Sodium atom has electronic configuration of 281. It donates one electron from its valence shell and acquires a stable electronic configuration of nearest inert gas configuration, resulting in a formation of positive charge cation. So here we have a normal sodium atom whose electronic configuration is 2, 8, and 1. Means 2 in the first cell, 8 in the second cell, and 1 in the outermost cell. Sodium somehow is not okay with this one electron. Generally, any atom has a tendency to achieve electronic configuration similar to the nearest noble gas. Nearest noble gas to sodium is neon. Electronic configuration of neon is 2, 8. Okay, therefore sodium tries to lose this one electron and have electronic configuration similar to neon. This is Na plus. Sodium as a metal had no charge in it, while sodium cation is positively charged. What is atomic number of sodium? We just discussed
11.
11.
11.
So how many protons are there in sodium? Number of protons. Protons are inside the nucleus. So sodium has 11 protons, right? So 11 positive charge. And how many electrons are there?
11.
11. So 11 negative charge. This is for a neutral sodium atom. But if suppose sodium loses one electron, okay, it would be left with like 10 electrons then, isn't it? Now just compare this positive and negative charge and tell what is the net charge on this sodium if it loses one electron. See, it has 11 positive and 10 negative. So 11 positive and 10 negative. Doesn't that mean a net 1 positive? Any neutral element, any neutral element has equal number of positive and negative charges. But if it loses some negative charge, like if it loses some negative electron, then the positive becomes extra, more than the number of negative. Therefore, it gains a positive charge. Can you tell me what is loss of electron? Is this oxidation or reduction?
Oxidation.
Oxidation.
Loss of electron is oxidation. Oxidation means loss of electron. Chlorine atom has electronic configuration of 2, 8, and 7. Means it has 7 electron in its outermost shell. Do you think it is planning to donate these 7 electrons?
No, sir.
No. Why?
Because it has only like 7, and like if it has one more electron, then it's like its outermost shell is complete. So why would it give away all
Okay.
the 7?
So you mean to say that taking one is a convenient option for chlorine than giving 7?
Yeah.
That's the point. Okay, good. Okay, that's what I want you to understand about these elements. 7 is there, so it better take one. Why to give 7? Okay, so chlorine atom has electronic configuration of 287, means it just needs one more electron to complete its octet and achieve electronic configuration of 288, nearest inert gas configuration, which is argon in this case, and results in the formation of negative charge ions. So chlorine takes one electron and becomes Cl minus. This process of gaining electron is called as reduction. So reduction means gain of electron. Positively charged sodium ion and negatively charged chloride ion are held together with ionic bond. Now sodium has turned into sodium cation because of loss of electron, and chlorine has turned into chlorine anion because of gain of electron. Now these two species formed after gain or loss of electron, okay, which is like a cation and anion respectively, has electrostatic force of attraction between them. That attraction is known as ionic bond. Summary of the story is sodium had one extra electron in the outermost shell, while chlorine had 7 electrons in its outermost shell. One day they meet each other, where sodium tells this chlorine that, see, I have one extra electron. If you want, I can donate it. Okay, this way you will also get an extra electron and your electronic configuration would be satisfied. I will also achieve electronic configuration of my nearest noble gas, neon. So this is the understanding between sodium and chlorine. Okay, so sodium loses one electron and it turns into a positive charge cation, Na plus. Okay, similarly, chlorine also gains an electron and turns into a negative charge anion, Cl minus. This is called as sodium cation, while this one is called as chloride anion. Now, nature says that a positive and negative charge species, if they are in close contact or if they are nearby, they start attracting each other. And due to this attraction, they stick to each other. And a positive and negative attraction are generally very strong attraction. It's not like a weak attraction. And they form a strong ionic molecule. Okay,
Yes.
here when I draw this diagram, this is called as complete structural formula for the formation of sodium chloride, where I've shown you exactly how many electrons were there in every cell of sodium and chlorine and how the transfer of electron is taking place. Let's see how the electron dot diagram of sodium chloride looks like. In this case, this sodium had one extra electron in the valence shell, means 281, right? So we're just drawing the valence electron and not all the electrons. Okay, now this arrow here shows transfer of electron from sodium to chlorine. So after that, chlorine gets one extra electron. And sodium now, after loss of electron, becomes positive charge. Chlorine, after gain of electron, becomes negative charge. So we put the charge, like the positive and the negative charge, outside that square bracket. Okay, this is how we draw electron dot diagram. Next, formation of calcium oxide. Calcium atom has electronic configuration of 2882. it denotes that it has two electrons in its valence shell. And in order to acquire electronic configuration of the nearest noble gas, it will like to lose those two electrons. Okay, and it will like to turn into a positive cation, because loss of electron, okay, leads to the formation of positive cation. But unlike sodium, calcium doesn't lose one electron. Calcium loses two electrons. So if it loses two electron, it gets 2 plus charge. And electronic configuration of cation formed is 288, because this 2 is lost. And this process is known as oxidation, just like oxidation of sodium. Oxygen atom has electronic configuration of 2, 6. This accepts 2 electron, okay, because it has 6 in the valence shell, right? So it accepts 2 electron and become a negative oxygen anion, O2 minus, with an electronic configuration of 2, 8. Now this positively charged cation, calcium, and negative charge oxygen combine together to form calcium oxide. This is the complete structural diagram for the change, where we can see that calcium is losing 2 electron to oxygen. Calcium overall has a 2 plus charge, and oxygen overall has a 2 minus charge. Same thing in terms of electron dot diagram can be written like this. Next is magnesium chloride. We'll start by writing electronic configuration for magnesium. What is electronic configuration for magnesium?
282.
282. Very good. What is electronic configuration for chlorine?
287.
287. Good. Uh, what is therefore valency of magnesium?
2 plus.
Magnesium is 2 plus and chlorine is
1 minus.
1 minus. Okay. So magnesium loses 2 electron to become Mg plus. 1 plus or 2 plus?
2 plus.
Chlorine takes 1 electron and becomes chlorine minus. 1 minus or 2 minus?
1 minus.
Okay. So now if I try to draw the electron dot diagram, magnesium had 2 electrons here and chlorine had 7 electron in the outermost cell. Is 1 magnesium sufficient for 1 chlorine? Like,
No, sir.
do you think a friendship between
No.
one magnesium and 1 chlorine is stable?
No, sir.
No.
No, because magnesium can give this 1 electron to chlorine. Okay, but still it will have 1 more left to be donated. Therefore, in this case, another chlorine is required, so that that other chlorine can take the other electron from from magnesium. Okay, after this, magnesium turns into a positive charge cation, Mg2 plus, and chlorine turns into a negative charge anion. Till early ninth grade, before you did like that atomic structure and chemical bonding, our only method we know to write the formula is the crisscross method. Okay, you can logically think, okay, magnesium has to give 2, chlorine has to take 1, so each chlorine would take 1 1. So 2 chlorine and 1 magnesium, so formula is MgCl2. That is, instead of drawing this 2 times, you can just draw it 1 time and put a 2 outside. Potassium oxide, who will like to explain?
So, potassium electronic configuration is 289, right?
No, it's not 289.
Then,
We just
288
discussed,
what?
yeah, we just discussed the whole table in the beginning. It's 2881.
oh, oh yeah, yeah, yeah. Yes.
So potassium is 2881, and what about oxygen?
Oxygen,
Hmm?
2 and 6.
2 and 6. So here potassium does what? It has 1 valence electron,
Yeah,
and oxygen has
6.
6 valence electron. So potassium gives 1, and we need 1 more potassium, because 1 potassium is not sufficient. Okay, so this also gives 1, and therefore potassium gets a positive charge. Other potassium also gets a positive charge, and oxygen with 2 extra electron now has a net negative charge. of 2 minus and 2 minus. Khushi, can you explain me the next one?
Yes, sir. So the electronic configuration of aluminium is 2, 8, and 3.
Hmm?
And iron is one second.
So iodine, I'll write for you.
So, so the valency of aluminium will be 3 plus,
Yeah, okay. Hmm.
and the valency for iodine will be 1 minus.
Hmm.
Uh, so we draw the a dot a configuration of both the elements.
Hmm.
So aluminium has 3 electrons in its outermost shell, and iodine has 7 electrons in its outermost shell.
Okay.
So 2 electrons from aluminium will um, can go to iodine to attain a stable electronic configuration.
But iodine needs only one.
Oh yeah, sorry, iron needs only one. So we need 2 more iodines. Yeah, which makes 3. So aluminium donates one electron to each iodine.
Okay.
Yeah, so it becomes Al 3 plus, Al 3 plus, and 3 whole. Yeah, then you yeah a common 3, and you draw the configuration for iron.
Like this.
Yes.
Formation of aluminium oxide.
So aluminum it's 2 8 so one second 2 2 8 283
2A3. Okay. And then oxygen,
8.
atomic number is 8. So electronic configuration is
Yeah, so that it'll be 2 and 6.
2 and 6.
Yeah.
Therefore, aluminium would lose electron.
Yes, sir, lose electron.
It loses, it has 3. 3
So
to,
uh it would lose 2, right?
okay, oxygen has 6. So oxygen needs 2. That this much is clear.
Yeah.
So
So
you are telling
aluminum
that
will burn.
aluminium will lose 2 to oxygen.
Or sir, once yeah, yeah.
See, this way this oxygen will get satisfied. I agree.
Yeah.
But I don't think aluminium would be fine with this because aluminium wants to lose 3. So what is clear that one aluminium and one oxygen is not a good composition.
Yeah.
So I
Uh,
think they may combine in some other proportion so that the give and take is same.
Oxygen needs 2,
This
right?
is giving 3, this is taking 2.
Yes, sir.
Valency is like plus 3 and minus 2. So in what proportion they combine so that the give and take is same?